A model for quantized motion of an electron in a uniform magnetic field B states that the flux passing through the orbit of the electron is nh by E, where n is an integer, h is Planck's constant and E is the magnitude of electron's charge. According to the model, the magnetic moment of an electron in its lowest energy state will be m is the mass of the electron. Now here it is said the electron is moving in a uniform magnetic field B and the flux through the orbit is nh by E. Now when an electron moves in a uniform magnetic field in a circular motion, the field is applied in a direction perpendicular to the magnetic field, that is the centripetal force mv square by r of the circular motion is equal to the magnetic force, that is EV cross B, that is EVB or EVB sin 90 degree. As the electron is moving in a circular orbit, so the applied field is in the perpendicular direction. So from here we can write V is equal to EBR divided by m. So this is the velocity of the electron, and in this problem it is said that the flux through the orbit of the electron. Now we know that flux is magnetic field dot area, so B into A. Now magnetic field and area is pi r square. Here the angle between the magnetic field and the area vector are in the same direction, so B dot A is BA cos 0. So B into pi r square is the flux, is equal to NH by E, NH divided by E, it is given. So the velocity is given, velocity is EBR by m, and the flux B into pi r square is equal to NH by E. Let's say this is equation 1 and 2. Now what we have to find? We have to find the magnetic moment of the electron in its lowest energy state. So in the lowest energy state n is 1. So the magnetic moment, now we know that magnetic moment mu is equal to current into area, I into A. Now current, so the here the electron moves, so the electron moves in a circular path. So the current is, that is charge, if E is the charge of the electron and T is the total time to complete one single rotation, then charge divided by time equal to current, that is E divided by time period T is the current, and area is pi r square. If r is the radius of the circular path, then E by T into pi r square. Now T is the time period. Now if r is the radius, then the total distance is 2 pi r, total distance, that is for once complete rotation it travels a distance 2 pi r and its velocity is v. This is the time period T. Time period is distance divided by velocity 2 pi r by v. So put the value of T, that is E divided by T, that is 2 pi r divided by v, into area, that is pi r square. So here 1 r cancels, pi cancels, that is E r by 2 E r divided by 2 into v. So E r by 2 into v. Now put the value of v from equation 1, that is E b r by m. So this becomes mu is equal to E r by 2 into v, v that is E b r by m, E b r divided by m. So this is becomes E square into r square into b divided by twice m. Now put the value of b r square from equation 2, that is b r square is equal to nh by pi e, nh by pi e. So this, let's say this is equation 3. So br square is nh by pi e. So e square mu becomes e square by twice m into br square is nh divided by pi e. So this becomes mu is equal to e square divided by twice m nh by pi e. Now n is 1. Now they have said in the problem, it is said that find the magnetic moment in its lowest energy state, that is n equal to 1. So n is 1, that is h by pi e. So 1 e cancels, so it becomes eh divided by 2 pi m. So the magnetic moment in its lowest energy state is eh by 2 pi m. So here eh by 2 pi m, that is option number 2, that is he by 2 pi m is the correct answer. Thanks for watching. Please like this video, subscribe my channel and share this video. Thank you.